Okay, so with your graphs, I would like you to do the following, and then you can complete this table. You've got one for concentration graphs, and you've got a second part for the surface area. So if I show you one, you can then repeat it for each of the different graphs you have. So your graphs should have this shape to them, okay? Now then what you need to do is take a gradient of the graph at the start of the experiment. As you can see here, it's imagining you're drawing a straight line that's a tangent to that, as if that was carrying on going straight. And from that, you make yourself a triangle shape. So I've stopped mine here purely because it makes the readings easier on my axis. So it's always a good idea to try and make it simple for yourself by doing that. And then what we have to do to find the gradient of this line, the gradient of this line is equal to the difference in the y-axis, so this is the y-axis, divided by the difference in the x-axis, this is the x-axis. So my y-axis is my volume, and my x-axis is time. So I can see here it goes from 0 to 20, so my volume difference, my y-axis difference is 20, and my x-axis goes from 0 to 10, so that's 10. Divide this out, I get an answer of 2, and this is 2 centimeters cubed per second. So this is telling me at the start of this reaction, the initial rate, the initial speed of this reaction, it was producing 2 centimeters of gas every second. And what you can do is do this for each of your graphs, for each of the different concentrations, and you can then compare the results for the rates of reaction to see if that helps to explain how they are changing. So for each one here, and I'll give you an example. Let's imagine that that was my concentration of 1 mole per decimeter cubed that I was using. I then put in here my working out for this, so all this working out would go into here, and I'd get a final answer of 2 centimeters cubed per second. And we should see the same happening in each of these, and then as you come down, the same here for your large, medium, and small size calcium carbonates.